Yeah, let us start session. Yes. So yesterday, second day started actual classes. So what is Java and the Java history and all that discussed. Okay. Yes. Today topic is about these features, Java features. Today topic. See JDK 1.0. JDK 1.0 released with main features as below. JDK 1.0 released with main features as below. First one, independent of platform. Next, independent of platform, portability, group language, scalability, and security. Okay. Yes. For JDK 1.0, released with main features as below. Independent of platform, portability, group language, scalability, and security. Okay, fine. Yes. To understand all these features, some basics required. Yes, to understand, directly can't understand these features. These features you cannot understand directly. Yes, to understand all these features, there are some basics. There are some basics required. There are some basics required. Like to, yes, about operating system. Yes, about ways. Next, about, yes, interpreter. About interpreter and the compiler. And the compiler. Next, about exe file and the dot class file. Okay. See, JDK 1.0 released with main features as below. Like independent of platform, yes, portability, group language, scalability, and security. These all are Java features. Yes, today's topic is about Java features. Yes, to understand these Java features, to understand all of these features here, yes, first of all, you must have some basics. Some basics like what is OS, about OS, how OS is working. Yes, when Java program is running, how OS is behaving. That knowledge. Interpreter, how interpreter working, and next how compile working. Yes, interpreter working, compile working. Next, what is exe file, what is dot class file. If you know these things here, then easy to understand these things, these topics here. Okay, now let us start with these basics here. Yes, here I'm starting with basics. Starting with basics. Starting with yes, starting with basics. Starting with basics here. Here, starting basics here. Yes, even non-IT background case also can understand. Non-IT backgrounds, non-IT backgrounds case also can understand. Can understand. Non-IT background case also can understand. From the very scratch, from the scratch, I'm starting this. From the scratch. Okay. From the scratch, I'm starting here. Okay, let us start from the beginning, from the scratch. See here, computer ware. Computer ware. Computer ware. Computer ware. Yes, computer ware. See, computer ware basically two categories. First one, yes. Second one, software. Hardware and software. Yes, computer ware basically two categories. First one, hardware. Next one, software. So, what is hardware? Hardware, these are physical components of a computer. hardware. These are physical components of a computer. Yes, hardware. These are physical components. Physical components of a computer. We can touch all these parts like keyboard, mouse, monitor, hard disk, RAM memory. Yes, all these hardware components you can touch it. We can touch. But this is not our part. Our part is software. Yes, about software. About software. Yes, we are the software engineers. So let us start with software. Yes, what is software here? See, in software, yes, everything is a program. In software, everything is a program. Yes, it's a collection. Yes, it's a collection of programs. It's a collection of programs such as C, yes, C++, yes, yes, Java, yes, Python, get different programs. All the programs comes on software. See, software. Yes, the software basically two categories. Basically two categories. Software basically two categories. Software basically two categories. Here software basically two categories. Software basically two categories. Software basically two categories. Okay. Yeah, started from very basics. I think no one expected this much of scratch. I think yes, started from the very scratch. Here my intention is you must have every knowledge. See, there are some unknown facts, even basics also, even these fundamentals. There are some unknown facts. Yet the guys who is having 10 years of experience also, they don't have this knowledge here. Okay. Yes, 10 years experience case also, they don't know about these some facts. There are some unknown facts. There are some basics. Okay, even 10 years experience guys also, yes, may not have that much of knowledge here. Okay, may not have that basics here. Just the basics. There's some unknown facts. There are some unknown facts. There are some unknown facts. Okay, 10 years experience case of they don't know about these unknown facts, these facts here, the basics here. Let us see. Software basically two categories. Software basically two categories here. Yes. First one, yes, system software. System software. System software. First one, system software. System software. Yes, second one, application software. System software, next application software. Okay. Yes, system software and application software. System software and application software. 1 second. Yes, Ajay. Just a minute. Voice not audible. Ajay. Yes, you guys can hear me clearly. Other guys, can you hear me? Hello. Yes, my voice is clear. Yeah, fine. Thank you. Thank you. Ajay, just you resign. Yes. Okay, fine. Thank you. Yes. Software basically two categories. First one, system software. Next is application software. Yes, system software. So what is a system software? What is a system software? System software, yes, it interacts. It interacts. It interacts with hardware components. System software, it interacts with hardware components. It interacts with hardware components. It interacts with hardware components. System software, it interacts with hardware components. See, software basically two categories. System software, next application software. See, system software, it interacts with hardware components. It interacts with the hardware components. For example, here, for example, yes, systems, operating systems, under device drivers. Okay, operating systems and device drivers comes on this category here. System software. It's a system software. Okay, next, what is application software? Yes, what's the application software? So what's application software? Application software. Yes, application software. Yes, this is yes for the purpose of application development. For the Yes, purpose of application, for the purpose of application development, for the purpose of application development. Application software. Application software. Yes, this is for the purpose of application development. Application software. This is for the purpose of application development. For the purpose of application development. Application software. This is for the purpose of application development. Yes, application apps. There are some apps. See here. See applications. See, in our daily life, we are using many applications. Yes, in our daily life, we are using many applications. You guys can tell me some examples of applications? Yes, you guys, can you tell me some examples of applications? Applications, examples. Yes, you can share in chat box. Here, chat box available, you can share here. Yes, some examples of applications. Good, good. Sri Lakshmi, good. WhatsApp, yes. So Facebook, yes. So WhatsApp, Facebook, WhatsApp, yes. Twitter, good. Twitter. Next, Flipkart. Okay. So these are the applications. Next, trading applications. Just online trading applications. Online trading apps. Okay. Yes, online trading applications. Yes, Google Pay. Yes, next. Yes, go to meeting, go to train. All these applications. Okay. Yes, food delivery apps. Okay. Yes, banking applications. Yes, the banking apps. There are different applications here. There are different applications. Okay, there are different applications here. Yes, to develop such kind of applications. See, to develop this kind of applications, we need some software. To develop this kind of applications, we need some software. That software is a application software. Yes, to develop this kind of applications, we need some software. That software called as application software. For example, here, yes, best example, application software, best example, Java. Java is application software. .NET is application software. Yes, Python is a application software. Okay, Python. Yes, Hadoop is a application software. Databases or application softwares. C language, next C++. So all these applications. Okay. Yes, exactly which is application software. Exactly which is application software. See, yes, more than 100 technologies we are using. Yes, like different kind of things like languages. Okay, like some packages. Yes, and tools like this. Yes, more than 100 technologies we are using the software field. In software field, more than 100 languages, packages, and tools, whatever it is. So exactly which is application software. There are some languages like Java, C language, C++, Python, HTML. Like there are different languages, packages like MS Office package, Oracle ERP, SAP ERP, some packages. Next, there are some tools like warehousing tools, testing tools, okay, reporting tools. Like there are different kind of tools here. So exactly which is application software. See, system software, it interacts with hardware components. Okay, yes, software which is interacts with hardware components is system software. Which is not interacting with hardware is application software. Yes, application software never interacting with hardware components. Never. Okay, so system software here is OS. Of course, device drivers are part of OS. Device drivers are also part of OS here. Okay. Yes, operating system. Operating system is a system software except OS. Except OS, all are application softwares. See, except operating systems. Yes, all are application softwares. All are application softwares. Okay, all are application software except OS. Except operating systems. Except OS, all are application softwares. That's it. Okay, 1 second. Let me show the document, your class documents. See guys, running notes is not necessary. Running notes is not necessary. Running notes is not necessary. Yes, I have prepared very clear documents. Yes, prepared very clear documents. Yes, see. So this is documents. Today's class started from basics. Today started from basics here. Yes, software. Software is a collection of programs. Okay. Software basically two categories. System software, next application software. System software. It interacts with hardware components. Examples operating systems and device types. Application software for the purpose of application development. These are examples of application software. Okay. See, except operating systems. Except operating systems. Yes, except operating systems, all are application software. Okay. So except ways, all are applications. That's it. Okay. See, in documents, I have prepared very clearly. Just you can follow the document here. Running notes is not necessary. You guys don't worry about running notes. I have prepared very clearly. Just you follow this document. Enough. Okay. Yes. See here, except operating systems. Except operating systems here. Operating system means like Windows is a OS. Linux is a OS. Unix OS. Yes, Windows operating system, Windows operating system, Linux operating system, Unix operating system, Mac OS. Like there are different operating systems. Except these operating systems, except this, all are application softwares. Okay. Yes. What is Java? What is Java? Yes, Java comes under application software. Java is application software. So before going to application software, let us see something about OS. Yes, about OS knowledge. Yes, how OS is working. Just little bit idea about OS. When you're running Java program, how OS is working. What is exactly OS? What is exactly OS? Let us see. Yes, something about OS here. So what is OS? Yes, what is OS? About OS. Yes, operating system. So what is operating system here? Okay. Yes, here some question for you guys. Some question. Yes. Can we run some question? Can we run any program? Any program? Yes, without voice. Can we run any program without voice? Tell me, guys. Simple question, very simple question. Coach, I'll explain everything very clearly. I'll explain just I'm asking. Just time your idea. Just I'm asking here. Of course, I will explain everything clearly. Can we run any program without voice? Yes, answer is no. Answer is no. Can we run any program? Can we run any program without voice? Yes, no. Yes, to run programs, voice required. Without voice, we cannot run any program here. Voice required. Okay. See, except bias. Except bias program. Except bias program to run all programs. All programs, voice required. Voice required. Okay, except bias. Except bias. Except bias program. Okay. Yes. Yes, except bias program. To run all programs, voice required. If no voice, no computer. Without voice, no computer. No voice, no computer. Compulsory voice required. Okay. Yes, without voice, your computer will not work. Voice required compulsory. Okay. See, except bias program. Yes, let me explain clearly. Yes, same point discussing. Yes, Sony Pandit, just wait. Same topic we are discussing now. Okay. Yes, except bias program. To run all programs for is required. What is bias? What is bias? So bias stands for what? Yes, basic. Yes, input and output. Basic input and output system. Basic input and output system. Bias stands for basic input and output system. Bias stands for basic input and output system. So exactly what is bias here? Bias is a hardware program. Yes, bias is a hardware. Bias is a hardware program. Yes, it's a hardware program. Okay. Yes, it's a chip level program. It's a chip level. It's a chip level program. It's a chip level program. In motherboard, there's a bias chip. In motherboard, bias chip. There's a bias chip. Okay. Yes. What is this bias? What is the purpose of bias? What's the role of bias here? What's the role of bias? See, bias is responsible. Bias is responsible. Bias is responsible to boot. Yes, to boot operating system. To boot operating system. To boot operating system here. Bias is responsible to boot your OS here. Bias. Bias is responsible. Bias is responsible to boot operating system here. Yes. What is booting here? So what is booting here? What is booting? Yes, booting. Yes, booting is a process. Booting is a process. Booting is a process of loading. Booting is a process of loading. Yes, OS from yes hard disk to RAM memory. Hard disk to RAM memory. Hard disk to RAM memory. Okay. Yes, booting is a process of loading OS from hard disk to RAM memory. Hard disk to RAM. Hard disk to RAM memory. Okay. Yes. See, bias is responsible to boot operating system. Yes, booting is a process. Booting is a process of loading. Booting is a process of loading OS from hard disk to RAM memory. So bias is the responsible for the booting your OS here. Booting OS. Okay. Yes. Right. See. So when system started, first bias activates. Okay. So once you power on your system, first bias program starts. Once you power on system, bias program starts. That bias program is responsible. That bias program is responsible to load the OS in RAM memory. So first bias programming start. Bias is a hardware level program. Bias is a hardware level. It's a chip level program. So once you power on your system, first bias starts. Before starting with, first of all, bias starts. Okay, that bias is responsible to load the OS into RAM memory. So once OS loaded into RAM memory, so bias is responsible to boot operating system. Booting is a process of loading OS from hard disk RAM memory. So bias is responsible. Bias is responsible to load OS from hard disk to RAM memory here. So once your system power on, once you power on system here, first bias starts. That bias program loads the OS from from hard disk to RAM memory. That's it here. So once loaded from hard disk to RAM memory, your system is ready. Okay, see here, system is like this. In system, layers like this. Let us see. Hardware. So hardware. Okay, hardware. See hardware. See on top of hardware, operating system. Yes, operating system. Yes, operating system. On top of hardware, this operating system. See, without OS, no computer. Without OS, no computer. Okay. Yes, even mobile phone also. Without OS, no mobile phone, right? Even mobile phone also OS required. Yes, here also same OS. Okay. So hardware, on top of hardware, OS is running. On top of OS, all the programs running, like C program or C++, or some Java program or some Python scripting here. Suppose Hadoop also on top of OS here. Hadoop Hadoop. So what databases? It's like there are different kind of things here. Databases. Yes, all these are application softwares. All these are application softwares. All these are application softwares. Yes, all of these things are application softwares. Yes, all these are application softwares. C++, Java, Python, Hadoop, database, like different kind of things. Yes, to run all these application softwares, we need ways. We need ways. On top of ways, all are running here. On top of, on top of ways, all are running. Like C program, C++, Java, Python, Hadoop, all the application softwares, all these application softwares. Yes, all the application softwares, all these application softwares running on top of ways. On top of ways. That means it's working like a platform. It's giving platform. Ways giving platform. Yes, ways giving platform. On top of it, all are running. Yes, ways giving platform. Ways giving platform. On top of it, all are running. That means ways is acting like a platform. Here, ways is acting like a platform. So what is operating system? See. So what is operating system? So what is operating system? What is operating system? Yes, first point. Yes, it's a platform. Yes, it's a platform. It's a platform. It's a platform. Yes, where we can run all the application softwares, all the application softwares, all the application software. Yes, all the application software. So what is operating system? What is operating system? Yes, it's a platform. Why is it a platform? So what is operating system? Yes, it's a platform. It's a platform where we can run all the application software. That's it. Okay, where we can run all the application software. That's it here. Okay, it's acting like a platform. Okay, see, Java features. Java is an independent platform. Platform means what? OS. That's it. On top of OS, Java program running, right? See, on top of OS only. So on top of OS, the Java program, C program, all the programs running on top of OS. It's like a platform. It's a platform. On top of it, all are running. See, Java is independent platform. Java is independent platform. Platform is OS. So independent of operating system. Java is independent of operating system. How is Java made us independent of operating system? Next topic. Wait. We'll discuss. So how is Java made us independent of platform? That reason behind of that we'll discuss. Wait. Okay. So before going to this topic here, some more topics. Yes, we will discuss. After that, we'll go to actual Java features. Okay. So what is operating system? What is operating system? What is operating system? Yes, it's a platform. It's a platform where we can run all the applications. See, not only platform here. See, all these programs are delivering some output. These programs are generating some data. These programs generating some data. So first of all, that data delivered to us. All the programs, output of all the programs, first of all, delivered to us and then transfer to output device, then transfer to output device, output device, output device. Suppose reading data from the keyboard, reading data from the keyboard. So first the keyboard data goes to waste. Keyboard data goes to waste here. Keyboard data goes to waste. From the waste, then transfer to this application software. That's it. So between application software and hardware, there is a waste. So like it's a middle layer between these two, like a mediator between these two. Exactly, you can say interface. It's an interface. OS is an interface between application software and hardware components. It's an interface. Yes, it is an interface. Yes, it is an interface. It's an interface. Yes, it's an interface. Yes, it's an interface. It's an interface between application software. It's an interface between application software and hardware components. And hardware components. And hardware components. Okay. Yes. What is operating system? What is operating system? Yes, it's an interface. Yes, OS is a platform where we can run all the application software. Yes, it's an interface. It's an interface between application software and hardware components. That is. Yes, next, one more point. Yes, in Java perspective, some point here. In ways, there's a library. 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 Yes, what is ways contains library? Every ways has its own library. What is this library here? Library contains all inputs, output functions. All input output functions. Yes, library is a collection of input output functions. Functions means C language functions. C language. See here, every way is developed in C language. Every way is like Unix base in C language, Linux base in C language, Windows in C language, Mac base in C language, Solaris. Yes, all these applications were developed in C language. All are in C language and here. So they are C language functions. Every ways has its own library, has its own library to communicate between application software and hardware components. Okay, next point here. Yes, every ways. Yeah, this is important point. To understand Java features. To understand Java features, this is very, very important here. See, every ways has its own, yes, every ways has its own libraries. 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 Every ways has its own libraries. Libraries, yes, to communicate. To communicate. To communicate between to communicate between application software and hardware components. Application software and hardware components. So between application software, hardware components, yes, there is library here. So every ways has a library with the help of library. So ways using library only, it will communicate with this here. That's it here. Next, one more important point. One more important point here. See these programs, C program or C++, Java, Python. Here these programs, first of all, linking with ways library. Of linking with ways library, communicating with hardware components. Okay, these programs, all the programs, linking with ways library. Of linking with ways library communicates with hardware components. Yes, it has to link. Every program has to link with ways library before going to start execution. Yes, before running program, before going to start running here, it has to link. Suppose C and C++, statically linking with ways library. Suppose Java and Python dynamically linking. C and C++ statically linking. Java and Python is a dynamically linking. Statically linking, dynamically linking, we'll discuss next page. I'll explain very clearly. What is statically linking? What is dynamically linking? We'll discuss. Next coming topic only. We'll discuss. Okay. So these programs, yes, all these programs, every program has to link with ways library before going to start execution. Yeah, this is very, very important for us. In Java perspective, this is very, very important. Yes, how C and C++ linking with ways library. Next, how is Java program linking with ways library? Yeah, that is tomorrow topic. Tomorrow topic. Okay. Yes. See every program, yes, every program has to link with every program has to link with ways library. Every program has to link with ways library. Every program has to link with ways library. Yes, before going to run. Before going to run it, it has to link. Okay. Yes, every program. So every program has to link with ways library before going to run it. That's it here. Yes, try to remember. Fourth point is very, very important here. Try to remember. Okay. Yes. Same topic, it's in document here. See this ways, about ways. Ways, it's a platform, it's interface. Okay. Every ways has its own libraries. Okay, next. Every program has to link with ways library before going to start execution. Yes, all these points repeated. Same topic expansion. Okay. See, you guys, running notes is not necessary. 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 Just you follow document here. Just you follow this document here. Same topic as this. Document in document, same topic is there. So you guys don't worry about running notes. So this is about topic stuff. Okay. Yes, enough. That's enough. To understand in yes, Java features. To understand Java features, this topic is enough. Okay, about voice, this much is enough. Okay. Yes. Java is a application software. So let us move to application software. Yes, application software. See, in application software, there are two categories: front-end software, back-end software. Front-end software, next back-end software. So what is front-end? What is back-end here? That is the front-end, back-end. See here, front-end, back-end. See, we are filling form, right? After filling, join to training. We are submitting that form, right? Okay, yes, this form is a front end. Yes, this form is a front end. This form is a front end. Okay, this form is a front end. So this front end collecting data from us, right? Collecting data. So this form collecting data from us. Okay, so this form interacting with users. This form collecting data from us. This form collecting data from us. So this is front end. So front end interacting with users. Front end interacting with end users and collecting data. After collecting data, storing it to some location. Storing it to some location. That location is called as backend. That location is called as backend. So backend is to store the data. So front end is to collect the data. Front end is to collect the data. Front end is to collect the data. Back end is to store the data. See here, front end. See front end. Yes, front end. These are to interact with end users. It collects data from end users and storing to back end. So what is back end here? Back end. You have to store and maintain data. Back end to store and maintain data. To store and maintain data. Yes, backend examples. Backend examples. Databases and files. Backend examples. Databases and files. Databases and files comes on this category here. Databases to store the data. Files to store data. Okay, front end. So front end, back end difference. Okay, yes, Java comes under front end here. See this form, behind the form, this is Java programming. JSP, it's a JSP. Behind of this form, this is Java program. Java program taking data. Java program taking data, storing it back end. So this is Java program. You say front end. Java comes on the front end here. Java is a front end. Java is a front end. Now let us move to front end here. In front end, languages and packages. So packages are ready-made and ready to use. For example, MS Office is a package. No coding. Here, coding is not necessary here. Yes, MS Office, ERP package like SAP and Oracle ERP, Tally accounting, all the packages comes on this category here. Here no coding. Yes, languages we should write the coding here. Java is a language. Java comes on the language here. Java is a language. Now let us move to language. Once again, see the way introducing into Java. How I am introducing into Java. Just try to observe that way of introducing here. See, started from basics, computer, hardware and software. Java is a software. So that's the reason started software. Java is a software. So started with software. In software, system software, application software. Java is application software. So next to move it to application software. Yes, application software, front end, back end. Java is a front end. So move to front end here. In front end, language and package. Java is a language. Now moving to languages. That's it. Okay, language. Now let us see. Language. Language. What's language? It's very simple. What's language? It's a media of communication. Language is a media of communication between two things. Language, it's a media of communication. Language is a media of communication between two things. Language is a media of communication between two things. Okay. Yes, software languages. See, software languages. Software languages. So what are the software languages? Software languages. Software here. First one, yes, computer. Computer. Yes, understandable. Computer understandable language. Computer understandable language. First one, computer understandable language. Computer understandable language. Second one, yes, user understandable language. Computer understandable and user understandable. User understandable. User understandable. Computer understandable. Next, user understandable language. Yes, computer understandable language. Next, user understandable language. So, what is user understandable language? User understandable language means like a C program or C plus plus Java and all this. Suppose C program, C program. For example, this is some C program. Yes, like English language, right? C program looking like English language. It's a user understandable language. Okay. Suppose Java program. Java program. For example, this is some Java program. Yeah, this is looking like English language. Python scripting, all these like English language. These are user understandable languages. These are user understandable language. Okay, next, what is computer understandable language? Yes, computer understandable language. See, what is computer understandable language? Computer understandable language. Yes, it depends on. Yes, it depends. It depends. It depends on generation of computers. It depends on generation of computers. It depends on the yes generation of computers. It depends on generation of computers. Computer understandable language. It depends on generation of computers. It depends on generation of computers. Yes, how many generation of computers? Tell me, guys. How many generation of computers? Anyone idea? How many generation of computers? How many generation of computers? No idea. Sony Pandey, no idea. Shivendra Kumar, 3 generations. Sri Lakshmi, five generations. Okay, fine. Yes, totally 5 generations. There are 5 generations. 5 generations. Totally 5 generations. Yes, first generation. What is first generation computer? What is first generation computer? Yes, what is first generation? See, first generation computer. Yes, it's a vacuum. Yes, vacuum tubes based computer. First generation. Yes, vacuum tubes. First generation vacuum tubes. What is second generation computer? What is second generation computer? Transistor based. Yes, transistor based. Second generation transistor based. Okay, next third generation. Third generation, yes, IC based integrated circuits. Yes, IC based integrated circuits. Okay, so first one vacuum based computers. Next is transistor based here. Next IC based. Is the electronic subject completely. Electronic subjects. Yes, in our engineering we have one subject electronics. Somewhat interesting this topic. Vacuum tubes, how vacuum tubes are working, transistors are working, IC based how it's working. Yes, very interesting. Okay. Yes. Next, fourth generation. Fourth generation. Fourth generation. It's a processor based. Processor based. It's a processor based computer. Yes. Now this is present generation. It's a present generation. It's a present generation. It's a present generation. Yes, feature generation. Yes, fifth generation is feature generation means yes, feature generation just to that feature generation, fifth generation. That feature generation, yes, within couple of years maybe releasing the market. Yes, 2025 or 2024 maybe chance of releasing markets. Yes, anyone idea? What is next generation computer? 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 Yes, no idea. No idea. Just yeah, going to release in the market. Yes, good. Such a good. Yes, Ranganatha Reddy. Yes, good, good. A based. In future, this A based computer. A based computer. See, processor based is a binary code. Processor based present generation. Processor based understandable, understandable, understandable language. Understandable language is a binary code. Is a binary code. Binary code like a zero response format. Zero response format. See, A based computer. Yes, A based understandable language. Understandable, understandable language. Yes, is a high level language. Means English language. High level language. High level language. Yes, once A based computer come to the market, things becomes very easy. Once A based computer come to the market here, software becomes very easy to work in software field. Very easy. Okay. Yes. So here this now currently is a processor based understandable language. Yes, binary code. So this is system understandable language. Binary code. This is now presently computer understandable language is zero response format. Presently computer understandable language is zero response format. That's it. So this is computer understandable language. Next user understandable language, English language. English language like a C language, C++, Java and all this. Okay, so languages in software, language are yes, two categories, two categories. First one, yes, low level languages, low level languages. Second one, high level languages, low level and 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 high level language. What is low level language here? Low level language, it's a system understanding language. Yes, it is a system understandable language. System understandable. It's a system understandable. It's a system understandable language. It's a system understandable language. It's a system understandable language. Low level language. It's a system understandable language. System means it's a processor. System means it's a processor. System means a processor understandable language. So what is processor understandable language here? Processor understandable language. Processor understandable language. Processor understandable language. Language, yes, in the form of binary codes. In the form, yes, in the form of binary codes. In the form of binary codes. Yes, zeros, ones format. It's a binary language. Binary codes. Zeros, ones formats. Binary codes. Okay, so this is low level language. Binary codes. Binary codes. Binary codes. Yeah, this is system understand language, processor understand language. Okay, yes, called as machine language. It is called as machine language. It is called as machine language. Yes, it's a machine language. It is called as machine language. Yes, it is called as machine language. Low level language, binary codes. It is called as machine language. Okay, next, high level language. What is high level language? See, high level language. High level language. Yes, high level language. Yes, this is yes, it's a user understandable. It's a user understandable. It's a user understandable language. It's a user understandable language. Okay, yes, it is like a, it is like a, it is like English language. It's 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 like English language. Yes, some question for you guys. Which is first high level language? Yes. Which is first high level language? Anyone idea? Yes, which is first high level language? Which is first high level language? Which is first high level language? Question. Question is, which is first high level language? Yes, anyone? Can you answer this? Of course, I'll explain. Just I'm asking idea. Which is first high level language? See, Java, Python, C, C++, HTML, all these languages are high level languages. English languages. All are looks like English language, right? Java program looks like English language. Python looks like a English language. C looks like English language. C++ looks like English language. R are like English language. These are high level language. So which is first high level language? Which is first high level language? Anyone idea? Yes, which is first high level language? Which is first high level language? Yes. Yes, right. Right. Yes, right. You are right. Okay. Right. Yes, Ajay, right. Yes, C Lakshmi, good. Yes, Shivendra Kumar, good. C language. Yes, answer. Yes, C language. C language. Yes, C language is a first high level. C language is a first high level language developed by whom? C language is a first high level language. C language is a first high level language. It developed by whom here? Any idea? Who has developed C language? Who has developed C language? Yes, Ajay, C Lakshmi, and Shivendra Kumar. Tell me. Yes, good. Yes, Nayan, good. Nayan Chaturvedi, good, good. Dennis Ritchie. Yes, by the Dennis Ritchie. Yes, by the Dennis Ritchie. By the Dennis Ritchie. By the Dennis Ritchie. Yes, in the year 1972. C is a first high level language. Yes, in the year 1972 by the Dennis Ritchie. Yes, about low level language, high level language. See, high level language. This high level language. Yes, every high level language program has to convert into binary code. Otherwise, system cannot understand C program or C++. Okay, Java and all these programs. Okay, so converting from, yes, converting from high level language to binary codes. Yes, we'll convert it here. Which one will convert from high level language to binary codes? High level language. Yes, C is a high level language. Java high level language. Python high level language. These high level language programs have to convert into binary codes. Which one will convert? Yes. Any idea? Yes. Which one will convert? Something has to convert. Something has to convert from high level language code to system understandable language. C program has to convert into binary code. Java program has to convert into binary code. C++ program has to convert. Yes. Who will convert here? Yes. Good. Interpreter. Yes. C likes me. Good. Interpreter or compiler. Yes. Interpreter or compiler. See, interpreter. Yes, interpreter. Yes, interpreter. Interpreter or compiler. Interpreter or compiler. Yes, interpreter or compiler converts. Yes, converts. 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 Converts from high level language to binary code. High level language to binary code. Yes, interpreter or compiler. Interpreter or compiler converts from high level language to binary code. That's it. Yes, what is interpreter? What is compiler? Yes, let us see about this most important topic. Yes, interpreter and compiler. So what is interpreter? What is compiler? Let us see. Yes, interpreter and compiler. About interpreter and compiler. Yes, let us most important topic. What is interpreter? What is compiler? Yes, interpreter and compilers. Yes, interpreter, compiler, both are to convert from high level language to binary code. But there is a difference. What's the difference here? First, let us start with the interpreter here. Interpreter. Yes, interpreter for this example is Python. Python is the best example for the interpreter based language. Yes, let us take Python. Python. Yes, Python, some test.py, some Python scripting. Suppose interpreter based language, Python scripting, or any interpreter based language. Okay. Yes, Python scripting, HTML scripting, Linux shell scripting, JavaScript, PHP, and Perl. There are different kind of languages. Yes, how interpreter based languages are working here. Yes, one second. Let me show practically. First of all, command prompt d colon, that will take to D drive, DER. Yes, this is test directory or test CT test folder. Okay, D drive test folder. So I'm at this location. Refresh. Yes, empty. Nothing is there. Yes, now check it DER. Nothing empty. 0 bytes. No files. Nothing. It's empty. Okay, now I'm writing some Python script. Notepad. Test.py. That Python. Yes. Cannot find test.py file. Do you want to create any file? Say yes. No. See some Python script example. Just for understanding purpose, I'm taking Python example. A equal 10. Suppose B equal 20. Yes, I want to add these two. C equal to A plus B. A plus B. Yes, C equal to A plus B. Yes, print. Now I'm displaying here. Print addition. Yes, print addition is equal to. Yes, displaying the result variable C. Next, C equal to yes, A minus B. A minus B. Print subtraction. Yes, subtraction. Subtraction equal to C, displaying C value. C equal to yes, A into B. A into B. Print yes, yes, multiplication is equal to yes, displaying C value. Okay, like this. Yes, very simple script. Very simple script. Addition, subtraction, and multiplication. Very simple script. Save, and exit. Okay, now see here. Desktop the Python script. Get this script running directly. Suppose if it's C program, you have to compile it. Checking for all the errors. If no errors, you have to run it. But Python scripting directly here. Python. Get the test.py. Yes, addition, subtraction, multiplication. Error checking not necessary here. Okay. Yes, how the script is working. Let me explain. How it's working here. The Python script. Yes, in that script first statement. Yes, next statement. Okay. So next statement. Okay, next statement. Okay, next statement. Okay, so next statement. There are some statements. In Python script. There are some statements like this. A equal 10, B equal 20, C equal to A into B, yes, A plus B, A minus B, like this. All these, right? The scripting statements. Here. Yes, how interpreter working on this? See, interpreter, first of all, checking for the first line. Syntax of the first line. Syntax means like, yes, like open bracket, close bracket. Okay. Open double quotation, close double quotation, some place, some comma placing here, semicolon placing, commas placing, brackets placing, double quotation placing. That is some syntax. Every language following some syntax. Okay, syntax. 1 second. Syntax. Suppose print open bracket, close bracket. That is syntax. Here double quotation and double open and close. Next comma. So the syntax. It says syntax here. Okay. Yes, here this is some text comma. Yes, variable C. Like it says syntax here. C programming is having some syntax. Java syntax. Python syntax. Syntax with some rules. Like open bracket and close bracket. For every open bracket, close bracket required. For every open double quote, close double quote. That is syntax. Syntax. Rules. Okay. Yes. If syntax means rules, every language has its own syntax. Okay. You are checking for the syntax of the first statement. Suppose if it is correct, that statement converts into binary code. Yes, if it is correct, simply converts into binary form, zeros ones format. See, interpreter checking for the first statement. Interpreter checking for the first statement. If first statement is correct, yes, simply converts into binary code. After that, generating output here. Generating output. Okay, so yes, simply converts into binary code here. That binary code given to processor. That binary code given to processor. Processor. Then binary code given to processor. Processor generating output. That's it here. Okay, yes, after that, see 1 second. Suppose first statement is correct, immediately converts into binary code and given to processor generating output. See, next coming statements may be right or wrong. Next coming statements are right or wrong. Interpreter never think about next coming statements. Interpreter never think about next coming statements. Right or wrong, it won't think about it here. Yes, if statement is correct, immediately convert into binary codes and given to processor generating output. So first line completed. After finishing first line, then it goes to second line. Checking for second line. Suppose second line is correct, same thing happens. Converts into binary code, given to processor, then execution. So first line checking and execution is completed. Second line checking and execution is completed. Like this line by line. First line completed, second line completed. Suppose next line something wrong. Next line something wrong here, simply stops. Some error message simply stops. That's it. Yes, it won't go for next coming statements. Once error comes, simply stops. Once any error, simply stops here. Let me show that. See, notepad. Suppose something wrong here, comma missing. Okay, here, suppose here this bracket missing. Okay, suppose here double quotation missing. There are 3 errors actually. There are 3 errors. Save and exit. Okay, now run it. See, I'm using up arrow key. It will maintain history. Up arrow key. See, running this is running. Python script is running. What's happening here? Line number 8 is error message. Actually, there are 3 errors. At 8th line error, once error comes, simply stops. At 8th line error, no, correct that mistake. 8th line mistake here. 8th line, comma. Yes, correction is the same. Save and exit. Yes, next again run it here. Yes, not 12th line error. That means only one error checking edit. Comes simply stopping. Once error comes, simply stopping here. Simply stopping. Okay, right? Yes, now correct this mistake here. The 12th line error. 12th line. So bracket missing, right? Bracket missing. Save it. Control yes, save it. Save and exit. Exit. Now run it again here. Again run it. Yes, again run it. Yes. Now 16th line. That means only one error. Yeah, this is showing only one error. It's not checking next errors. It's not checking. Any error comes, simply stopping here. Any error comes, simply stopping. So this is working of interpreter. Yes. No error. Simply output. It shows only one error. It shows only one error. This is working of interpreter. Suppose if it is compiler, how it's working. Let us say about compilation. Same thing about compiler. Yes, how compiler is working. Yes, let us say about compilation. Compiler. For compiler, let us take C programming. Compiler. Yes, compiler. Yes, C program. For this, let us take C program for compiler. So about test.c, some program. Yes, how compile is working. See, compiler checking for the first statements. C program. For example, this is C program. Let me open C program also. Yeah, this is C program. Opening. Turbo C. It's a Windows based. Windows based. Windows based C language. It's opening. Yes, open here. C. Save. Save. See this program same addition, add, subtract and multiply two numbers. This is C program. So if it is C program, first of all you have to compile it. Comparison success. Success. Okay, fine. Yes. In C program, what happens here? In C program, yes, what happens? How compile is working here? Compiler. So first of all, compiler checking for the first statement. Suppose first statement is correct. Even it's correct, it won't convert into binary code. No, it won't convert. It won't convert into binary code. It won't execute. Next, checking for next statement. Suppose next statement also correct. It won't convert into binary code. So first of all, checking all the lines from top to bottom. Checking first line, next line. Suppose next line some error. Error at third line. Error at third line. After checking for next line also. Suppose next line correct. Then checking for next line. Like this, compiler checks the whole program from top to bottom. Maybe C compiler or C++ compiler or .NET compiler. Any compiler. Checking whole program from top to bottom. Checking all the statements. Checking all the statements from top to bottom. Checking all the statements from top to bottom. Checking all the statements from top to bottom. Top to bottom. Checking all the statements from top to bottom. Checking all the statements from top to bottom and shows all the errors. It shows all the errors. It shows all the errors. It shows all. Compiler shows all the errors. See this. Now, see here. Suppose C program there are some mistakes. Suppose here by mistake semicolon missing. Suppose here comma missing. Okay. Suppose here bracket missing. Suppose here double quotation missing. Okay. Suppose here semicolon missing. Yes, here some bracket missing. Yes, now save it. Saved. Yes. Alt C. Compilation. Compile. Now I'm compiling. See this errors. All the errors. How many? There are 10 errors. 10 errors. All the errors from top to bottom. See this. So the first error. See at the bottom. So the first error. 16th line error. 22nd line error. 25th line error. 27th line error. Next line. 29th line error. Yes. Next line like 36th line error. 38th line like this top to bottom. Compiler shows all the errors from top to bottom. See all the errors. So compiler checks the whole program from top to bottom, shows all the errors. No, correct all the mistakes. Semicolon missing. Yes, here comma missing. Comma missing. Comma missing. Okay. Yes, next. Here this is double quotation missing here. Okay, next here semicolon missing. Okay. Yes, next here some bracket missing here. Yes, now compile. Yes, still one more error. What is that error here? Scan. Yes, bracket missing. Here bracket missing. Compile. Success. Success. Yes, if no errors, what happens? Let us see that also here. Suppose checking all the errors. Suppose everything is fine. Suppose everything is fine, no errors. Everything is fine. Top to bottom. Top to bottom. All the statements are correct. Top to bottom. All the statements are correct. Top to bottom. Every statement is correct. No error message. If no error message, then what happens? If no errors. If no errors, what happens here? If no errors. Just a minute. 1 second. 1 second. Just a minute. 1 second. 1 second. Just a minute. Yeah. So let us continue. Yes. Suppose C program compiler. Compiler checking top to bottom all the statements. Suppose if no errors, what happens? If no errors, what happens here? Then compiler opens another file. Just the compiler opening another file. Compiler opens another file. It opens another file. After opening another file, yes, it converts whole codes from top to bottom into binary codes. Get the C program into binary codes like zeros ones formats. All is zeros ones formats. Zeros ones formats converts into binary codes. Yes, whole code from top to bottom converting into binary codes. Converts into binary codes and write to second file. Get this whole code top to bottom convert into binary code and write to second file. This second file is called as exe file. It's exe file. Exe file means executable file. Here this is given to processor. Given to processor. This exe file given to processor. This exe file given to processor. So processor taking that exe file and executing and generating output at a time. That's it. Now what's the main difference observed here? See this 1 second. This program backend of this program. This program backend here C drive, C turbo C, yes bin in this yes C program. This program This program is a math.cpp. It's a math.cpp. CPP and C language both are C++. It's a C++. C++, C language both are same. Both are same here. Now math.cpp. Okay. Yes, what happens here? See, when you compile this one here, compile, yes, no error. Okay, now run it. When you run it here, what happens here? See, one file create here. Application, this math application, that is exe file. That math.exe file created. Math.application.exe file created. Yet this exe file executed now. Finally, exe file executed. Yes, enter first number 10, second number 20. Yes, addition, subtraction, and multiplication. Now what happens here? Compiler generates one exe file and executes finally. So this is main difference between interpreter and compiler here. That exe file is reference. Yes, let me explain the differences here. Yes, interpreter versus compiler. Yes, interpreter. Yes, interpreter. Interpreter versus compiler. Let us see the difference here. Difference between interpreter and compiler. Let us see the difference here. Interpreter and compiler. See, first one interpreter, next one compiler. The differences. So what's the difference here? Interpreter versus compiler. See, interpreter. Yes, first difference. Yes, it checks the code. It checks the code line by line. It checks the code line by line. It checks the code line by line. What is compiler? Yes, whole program from yes top to bottom, from top to bottom. Whole program from top to bottom. Yes, interpreter. It checks the code line by line. Compiler, whole program from top to bottom. Right. Next, interpreter. Yes, it shows only one error. Only one error, right? Compiler, yes, all the errors. It shows all the errors from top to bottom. It shows all the errors from the top to bottom. From top to bottom. From top to bottom. Yes, very clearly explained here. Practically showed. Okay. Yes, next. Next, main difference, exe file. Yes, interpreter. Yes, it does not generate. It does not generate exe file. Yes, compiler, it generates exe file. This is main difference. Interpreter and compiler difference. Main difference is generates exe file. What is exe file? We'll discuss. Exe file dot class on independent platform. That is tomorrow topic. Okay. Yes. Interpreter does not generate exe file. Compiler generates exe file. Okay. Here this exe file. Here don't have exe file. Okay. See here. Interpreter based language. See Python scripting. Directly scripting executing. No exe file. Directly source code executes. Okay. Yes. It executes source code directly here. Yes. It executes source code. It executes source code directly here. It executes source code directly. Compiler, yes, it executes exe file. It executes exe file. Okay, see here. Yes, interpreter, it executes source code directly. Only source code. Source code means this is source code. That Python scripting, yes, that English language. This is called a source code. What are the program we are writing? Our code is a source code. That source code executing directly. But in case of compiler, what happens? Exe file generating and executing here. Okay, see interpreter based language. Yes, or scripting language. These scripting language. These are scripting languages. Yes, compiler based. They are programming language. Programming language. Scripting language and programming language. Scripting language example. Scripting language examples. Yes, Python is a scripting language example. Python. Okay, HTML, Yes, JavaScript. JavaScript is not a Java. Java is different, JavaScript is different here. Next, yes, PHP, PHP. Okay, next, Perl scripting, the scripting language. Programming language examples, C language. Compiler based example, C language, C++. Next, .NET. Correct. So this is difference between these two here. See, interpreter based language. See, interpreter. This interpreter based language, based language, yes, based language don't have exe file. Yes, here everything is exe file. Everything, yes, everything, yes, everything, yes, is an exe file. Everything is an exe file. That's it here. So exe generating and executing. Yes, interpreter based language don't have exe file. So this is difference between interpreter and compiler. Okay, same topic explain document also. See the document. See all these software languages. Yes, low level language, high level language, generation of computers. I think you guys not expected this level of basics. I think you guys are not expected. Okay, not expected this much of basics here. Yes, from the very beginning started here. See, interpreter and compare the differences here. Interpreter and compare the differences, all the differences. Okay, now here. Okay, fine. Just talking about all of different languages. But Java, where is Java? Yes, what is Java? Is it interpreter based or compiler based? Yes, for that purpose, I have to explain about Java, how Java is working. Once explained, you can tell. Is it interpreter based or compiler based? Yes. Tomorrow, introducing Java. Tomorrow, how Java is working, Java features and all that, tomorrow will continue. That's all. Yes, tomorrow, Java, how it's working, is it interpreter based or compiler based? Yes, about that topic. Next, Java features. Tomorrow finishing Java, all that features here. So next class going for installations. Okay, yeah, that's it. Yes, same. 6 to 7:30. No changes. 6 to 7:30. Yeah. So that's all. So thank you guys. See you tomorrow. See you tomorrow.